Hello. Our goal today is to understand and work with proportions. Make sure that you have your toolbox ready or your notes, and we'll begin with the definition.
When we are talking about proportions, we are talking about two equal ratios. So an example here is a ratio of 2 girls to 3 boys. And then here we have a ratio of 4 girls to 6 boys. And if we look closely, we'll notice that here's 2 girls, here's 3 boys,
And here's 2 girls and 3 boys. 2 girls and 3 boys.
So as a set, you can see that they are the same, so that means they are equal. Once you find 2 equal ratios, you have now formed a proportion. We can also apply it with rates. So here we have $3 to purchase 1 book, and here we have $9 to purchase 3 books. So if I circle the set, here's my 1 book for $3.
And to match that up, I should be able to circle 1 book for every $3 signs. Ooh, too big.
Alright, so here we see these sets match the same as these, which means that they are the same, and that's how you form a proportion.
Your job is going to be to determine and prove if ratios, a set of ratios and a set of rates, or a set of rates, form a proportion. There are basically 3 methods that we're going to go over, and you're going to choose the one that works best for you.
The first method is the simplifying method. We're going to apply it a little bit differently for ratios and for rates. We've already worked on simplifying ratios, and we've already worked on simplifying rates. Starting with our ratios, remember our rules were to put them into fraction form. These ones already are. And then we're going to make sure that they're in the same units. This one doesn't have the units, so don't have to worry about that step. And the last step was to, if they have a common factor, to divide by that common factor. 3 and 6 have a common factor of 3. So I am going to divide both of these by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 4 and 8 have a common factor of 4. So I am going to divide by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. If after simplified, they are the same ratio, that means that 3 to 6 and 4 to 8 form a proportion. So I can now write in my equal sign. They are the same. I proved it by simplifying.
When you're dealing with rates, remember rates are comparing 2 different types of units. So here we have 7 inches in, say, 9 hours compared to 42 inches in 54 hours. So we want to know, are these proportionate? Right? Can we put that equal sign in between? Now remember that rates are a very particular kind of ratio, and what we do here is we want to find the unit rate. And so we want to remember to find rate, unit rate. We divide the denominator and the numerator by the denominator. So in this case, I'm going to give you that. All right. And since our denominator is 9, I'm going to divide both by 9. And I am going to get,
and 7 divided by 9 is 7/10 repeating.
Okay,
over, and then 1 hour.
All right, you need a calculator for that one. So here, our denominator is 54. So remember, for a rate, we have to do the same thing, dividing both by 54 to find the unit rate. So my numerator,
and this one also is 7/10 repeating.
All right. So what that shows me is because these are the same, these 2 rates are proportionate. They form a proportion. That method is called the simplifying method. Another method that you may choose is called the horizontal method. Let's take a look at why.
If we notice in this first problem, 5 to 4, they don't have any factors in common. So it's already simplified. So what I can look at and see, well, if this is a simplified, could I make an equivalent ratio that's the same as 5/12? If I did, 4 times 3 is 12. So 5 times 3 is 15. So I notice that these are now equal. So I can write here 5/4 is the same as 15/12.
So, because this is the horizontal method, we're comparing them from side to side, and I'm looking at 8/4 compared to 12/8. Well, this one was pretty easy to do mental math. I can even see to get from the 4 to the 8, I can multiply by 2. To get from 8 to 12, nothing times 8 gives me 12. So right off the bat, I know that this is not going to be proportionate. But if I didn't know that, I could go backwards and I could think, well, 8 divided by 2 gives me 4. 12 divided by what gives me 8? I don't even know. Do we have to figure it out even if we know that this isn't going to work?
Nope, I would say until it doesn't work. All right, we have a new symbol that you're going to be writing down in your notes. Mrs. Armentrout will write it on the side here. Write that in your notes also. If you take the equal sign and put the slash through, that means not equal to. So 8/4 is not the same rate as a ratio as 12/8.
The last method that we're going to show you is called the cross product method. And it's just like it sounds. Product means to multiply. Cross means you're going to go in a cross or diagonal. So let's see what that looks like.
So if I circle my diagonals, I'm going to put a multiplication sign in between and I will multiply. If there are numbers that you would like to use your calculator for, take out your calculator and use that. I'm going to write down what my product is down on the bottom here. So 9 times 8 is 72. I'm going to make the diagonal with the other two numbers also. So I have 6 times 12, so I have 72. If both of these products are the same, that means that you are going to be forming a proportion. So then I can write 6/9 is the same or equal to 8/12.
All right, here we have an example with numbers that aren't maybe as readily multiplied in our brains. So we're going to follow the same procedure, but this time we're going to demonstrate it with the calculator. So 14 times 51, notice it doesn't matter which way I start as long as I go in the diagonal.
And that product is 714.
All right, and we go the other way and we have 17 times 42.
And that product is also 714.
Meaning that 14 to 17 is proportionate or the same as 42 to 51. Remember that with these three methods, you can choose the one that works best for you. What we're going to do now is apply this to some word problems. In our first word problem, we have Alex completed 40 push-ups in 2 minutes. Nice job. Eli completed 57 push-ups in 3 minutes. Wow, you guys are pretty strong. Now we're trying to determine if these rates are proportional. We're going to explain why, so we have to have proof. Let's start by circling our key information. We've got 40 push-ups in 2 minutes. And so Mrs. Lesh is going to show you the comparison.
So we are comparing push-ups to minutes. I want to make sure that I write both of my rates in the same form. So for Alex, we're going to have 40 push-ups and 2 minutes. For Eli, we're going to have 57 in 3 minutes. Now remember, we have several choices to decide if these are going to form a proportion. We could, because these are rates, we could divide by the denominator and simplify with the unit rate. We could use our cross products and see if those products are the same. Which would you like to use, Mrs. Armentrout?
Ooh, let's find a unit rate.
Okay, let's find the unit rate. I'll get the calculator.
All right, so when I find a unit rate, that way we can kind of see, well, in 1 minute, how many push-ups could each of these young guys do. So 40 divided by 2 and 2 divided by 2. So that's going to, well, that one we can just do in our head, that 20 to 1. So in 1 minute, we would expect Alex to complete 20 push-ups. Here, I want the unit rate, so I'm dividing both by 3.
Now, if you don't know, use your calculator. I know that's 19, so Mrs. Armentrout's going to write a 19, and we notice that, oh, those are not the same unit rates. So are these proportional? The answer, no.
Now notice that it says explain, and you do not want to make the mistake of answering without an explanation. Your work here is a starting point, but you would probably want to add on no, because 20 to 1 is not equal, oh, let's use our new sign, to 19 to 1.
The next part says, if not, and we said no, rewrite one of the rates so the push-ups are proportional. So Alex, let's use his. He had 40 push-ups in 2 minutes. And for Eli, well, we need to change that because we want to also have it be the same. Now notice that when we already wrote the unit rates, it had to be 20 push-ups in 1 minute. So we might say that Eli completed 20 push-ups in 1 minute, because these are the same. So this would be for Alex, and the new one that we would write for Eli, we're going to change his amount of push-ups. So we have 20 push-ups to 1 minute.
Let's take a look at one last example. So your word problem reads, Liz ran 3 laps in 1.5 minutes, or 1.5 minutes, while Sammy ran 24 laps in 12 minutes. Again, are these rates proportional? Explain. Start by figuring out what 2 things you're comparing. Okay, so after you figured out your information, we know that we are comparing the amount of laps to the amount of minutes. Jotting this down helps you remember what number to put on the top and what number to put second. So you need to make sure that that stays the same.
All right, so Liz ran 3 laps in 1.5 minutes, while Sammy ran 24 laps in 12 minutes.
Let's try a different method. We used the unit rate last time. You feeling like a cross?
Sure, let's do
product?
cross products.
Let's do that. All right.
So circling our cross products, I'm going to begin here. I'm going to put my multiplication sign in. I'm going to hand Mrs. Armentrout the calculator.
All right, we've got this covered. And it's 36.
In the opposite diagonal, I have 3 times 12, which we don't need a calculator for that one. I know 12 times 3 is 36. So I notice that both of these products are the same. So are they proportional? Yes. And then Mrs. Armentrout will write our explanation.
All right, here we go. Since I know that both of the cross products are 36, I know that these are equal to each other.
We can write the cross products are both 36.